Good afternoon, everybody. Hi, and welcome to Manage Your Infrastructure and Configuration on AWS, a webinar part of the Modern Application Web Day here at AWS. So let's get started. First of all, let me just show a quick agenda. What are we going to talk about today? So I'll do a quick intro. I'm going to talk about how did we used to do it? What is infrastructure management? What is configuration management? How can we automate it? A bit of a recap, and at the end, the glorious Q&A. So if that's all well and done, let's get started. First of all, who am I? Who are you talking, or who are you listening to right now? So my name is Darko Meszaros. I am a solutions architect for Amazon Web Services. I'm based in Berlin, Germany. And it's good to put a face to a voice right now. So that's me. I do like plaid shirts. Going on. So what are we going to talk about today, and how did we used to do it? So today's talk is about configuration and infrastructure management on AWS, and how is it done in the modern world. So let's start off by talking about how did we use to manage infrastructure and configuration? How was it done before? So let's take an example of here. A sysadmin, let's name him Bob. Bob wants to use AWS. He has his application. He wants to run the application on AWS. In the old way, he goes to AWS, he does a bunch of clicks, clickety-click, and bang, he creates a load balancer, he creates some EC2 instances, he creates a database, right? That's a quick way to get started, right? It's simple, effective, and easy for everybody. Now, when we have these resources pre-created, so we have created our infrastructure this way, so our infrastructure in this case is an EC2 instance, a load balancer, and a database, we need to find a way to how to configure said infrastructure. So what Bob would do, Bob would SSH into the web servers and install Nginx, configure all the settings he wants. He would copy the website over, the application over. He would potentially configure the load balancer, do a migration of the database, all of that, which works. Yeah, it's something that a lot of people have been doing for a long time. There's also a few shortcuts Bob can take. Bob can use user data on EC2 so that each of these instances actually start up with certain configuration and all that. So that's fine. But there's a problem with this. Problem with using the old way in the cloud, right? We like to talk about the cloud as something quite scalable, very elastic. It can adapt to a lot of things. And if we approach this the old way with a lot of clicking, that's not scalable. So, I mean, if Bob configures his instances once, he would have to do it for each new instance. So if we have to scale along with load or with the increase in our traffic of our web application, that means we have to get Bob to click a bunch of times, get us new EC2 instances, go into those EC2 instances and actually perform the configuration of it. So that's not ideal. And again, it's not elastic. It's it's not very flexible. It requires Bob, and Bob is not flexible. Again, we need to document. So limitless documentation procedures. We all know how much we love to document. So if for every change we make, we need to make a documentation change. Hey, something has changed. We installed a new version of Nginx. Not quite good. And if we wish to replicate our environments for, let's say, testing or Q&A or staging or something we want to play with, it's not very easy to replete and replicate because we have to get Bob again to go and click, remember what he did or read the documentation he wrote and do it a bunch of times. And this comes to scalability. It's not very fast in reaction to changes. If we wish to install a different package version across our entire fleet, again, Bob has to log in to each of these instances and make that change, which is not the fastest of things. So what can we do? What's the solution here? So let's delve into infrastructure and configuration as code, right? we all love to code, right? So what if we can actually present all of these changes on all of these clicks Bob does as a piece of code? That would be amazing, right? So that would save us from a lot of unnecessary clicking, a lot of unnecessary SSHing, and potentially Bob making a mistake every time he tries to repeat what he did before. So let's separate this out. First of all, let's talk about infrastructure as code. What is infrastructure as code? In the Amazon sense, it's a bunch of configuration files, JSON or YAML, that describe your infrastructure. They basically describe the components and settings of your AWS infrastructure, from EC2 instances, from RDS databases, VPCs, subnets, security groups, instance roles, and all of that stuff. It's scripted. So in this case, we actually tell, well, it's scripted and declarative at the same time, where we declare which resources we want. And if we wish to configure resources with CloudFormation, which is not the best thing to do, I'm talking about EC2 instances, you can use the script to do that. Again, one of the great benefits of infrastructure as code or anything as code here is that we can version control it. With version control, we can more easily replicate and find issues and track changes we've made to our infrastructure. If we treat our infrastructure as a piece of code, as our application, we can apply all the same best practices we use in code development to infrastructure development, right? And in AWS, the tool of choice, of course, is our native tool called CloudFormation. So AWS CloudFormation, as I mentioned before, allows you to declare AWS resources or your infrastructure in the terms of a piece of code, a template. This template is something like either written in YAML or JSON. And within this template, you can define settings and resources for each piece of your infrastructure. CloudFormation resources are grouped in logical units called stacks. So we can create Bob can go in and create a stack that contains all the infrastructure he needs for his web server, including his EC2 instances, his load balancer, his networks configuration, all the IAM policies he needs, even the database. He can do that. And Bob can, at the same time, manage multiple stacks on CloudFormation, which is quite nifty, right? And this is a quite potentially hidden feature of CloudFormation, is that you can actually export your CloudFormation templates as, well, nifty little diagrams, right? This is done using CloudFormation Designer. So this is it. You can point this to somebody and say, hey, I've written a piece of code in JSON and it looks, well, it makes my infrastructure look like this. Now, Bob has created the infrastructure. Bob has written a CloudFormation template that will actually provision all the resources he wants. How do we configure said resources? What do we do with them? So, in comes configuration as code. So, after we have provisioned the EC2 instances that will serve as our web servers, we need to find a way to configure them. We need to find a way how can we install pieces of software on them? How can we potentially create users on these instances? How can we enable services, change the configuration of Nginx, for example, right? So here's what configuration as code or configuration management as code can help us. Like before, we also have the benefit of version control. Configuration as code is declarative code. And declarative code, again, depends on what configuration management engine are we using. Is it Chef, Puppet, Ansible, SaltStack, CF engine? It really depends on that. You can have various resource providers. So for different types of resources running on your EC2 instances, you can have them providers. And this is one of the benefits of communities. So each engine of, be that Chef, Puppet, or Ansible, or anything else, has potentially a larger community, and the sharing of knowledge between people, or creation of those modules, cookbooks, and playbooks, and runbooks, right? Give you the flexibility to not have to rewrite your code. There's as same with application development, there's testing frameworks. So for a lot of configuration management frameworks, there's testing tools. There's tools that can actually test your configuration code before you put it into production. That means that you can test this code without potentially breaking something running in your production environment. And portability, this means a lot of the same code can be reused on different systems, including different operating systems and even different organizations. So if you have a big organization, have multiple environments, you can reuse, you can have a same code base to do multiple stuff. So Bob will never be alone. Now, what I'm going to actually show today is when it comes to configuration management is the use of AWS Systems Manager with State Manager plus Ansible. So AWS Systems Manager is a tool that helps people who use AWS with a lot of operational tasks, including configuration management, which is not necessarily operations, but with State Manager, we can ensure that our instances instances being managed by Systems Manager are kept in a certain state. And thanks to Ansible and Ansible's flexible code and configuration management syntax, this makes it very easy for us. So back to configuration as code. What is configuration as code used for mostly? Installing packages, of course. That's kind of the basis of it. Configuring users. This is where you wish to add new users to your servers. Configuring server settings. Let's say I deploy Nginx on my system and I wish to have multiple websites running on it for some reason, or I wish to change the port. I can actually do it using configuration management. Setting up services. Now, a lot of people come to me and ask me like, okay, Darko, so you're talking about configuration management, but hey, we have containers and we do have serverless and all that. Still, some people have to be running things in a more traditional way. They run their applications on actual servers, or they have problems adopting containers for some reason, and they wish to approach this in a more or in some sort of interim period, like, hey, we can't migrate to containers right now, but we wish to use all the benefits of the cloud. That's one of the reasons you want to have configuration management. Is if I want to make changes to my infrastructure on the fly without having to replace my instances in case of an immutable environment, configuration management is the way to go. So I don't have to rebuild my infrastructure every time I make a change. I can just allow the configuration management engine, in this case Ansible, and Systems Manager do that for me. So System Manager is actually going to run Ansible for me. I can tell it, hey, run a playbook for me, and run it on schedule. So in the case I'm going to show later on in the demo, we actually use Systems Manager to run Ansible every 30 minutes to a subset of instances. So which is usually enough, but this can actually be tweaked if we wish to do this on some other way. So this is all fine and dandy, right? So we have CloudFormation, we have Systems Manager with Ansible, that Bob can take a bunch of these templates that he has on his laptop, and he can upload it to S3, and he can put it as in CloudFormation to create a stack, which is all great, right? But there's still a bunch of clicks, right? There's still a lot of things Bob has to do, a lot of clicks he has to make to do this. And with clicks, you get potential errors and potential mistakes. It's not the best thing. So Bob writes his little template, he logs into the web console and click. He updates the CloudFormation template, and for some reason he changed the instance profile, or he changed the size of the instance, and now your application is down because again, Bob didn't do it manually, but he made a mistake in his template, and now, well, instead of one instance going down, you actually broke a bunch of them. So it's not ideal. So in an ideal world, or something we strive to, we would like to have some sort of magic here. So we can have Bob write his templates and do a little git push origin master, and poof magic, and all of that is deployed. All that is either uploaded to S3 bucket, it's set up in Systems Manager, or it's actually updated with the CloudFormation template. Is there something we can use to help us with this? Well, so we have AWS Code Services, which is a suite of tools. Well, usually they're called developer tools now, right now, I believe, that can help us in this. So as I mentioned before, if we treat our infrastructure and configuration as an application, we can reap all the benefits of best practices when it comes to application development. So as it comes to any application change release steps, from the sourcing, building, testing, and actually deploying, we can utilize the services we see here on screen, from AWS Code Commit, which is our managed Git repository, to AWS Code Build, which is our building framework. So this Code Build allows you to build packages, build artifacts that can come from Code Commit, and AWS Code Deploy, which actually helps you deploy that piece of code somewhere. And all of this is actually packaged nicely in AWS Code Pipeline, which, as the name says, is a pipeline. So it actually manages to get the code from one end to the other. And we're going to be using this today in the demo to show off how can we apply these code development best practices and tools to actual infrastructure development and code configuration development. So, a tale of two pipelines. What you see here on screen are screenshots, rather cropped screenshots, from two pipelines I have created for the sake of this webinar. The one on the left actually works with CloudFormation. It ingests Bob's updated CloudFormation template, builds it. In this case, it doesn't actually build it. In the build stage, we use code build to test the templates to make sure they're up to snuff. And in the deploy phase, we actually update the running CloudFormation template. On the right-hand side, we kind of have the same thing, but the deploy phase is not as clear cut as the one for CloudFormation, and this is for Ansible. So what we are doing is we are ingesting Bob's Ansible playbook, putting it into code build, running a piece of linter software on it, or whatever we want, and then uploading that Ansible playbook to S3, which is again from then being accessed by a systems manager and run on our nodes. So I think I've talked enough. Well, I'm going to continue talking, but I've done PowerPoint enough. I think it should be time for me to show you how this works. So everybody's favorite time, demo time, and let's hope the demo gods are on our side. Okay. So what do I have here? So if you can see here, I'm using Cloud9, which is our web-based IDE. I find it very useful for developing pieces of code for AWS. So what I've done here, I've created two Git repositories in Code Commit, one for CloudFormation and one for my Ansible playbooks, which will deploy to their respective systems, so either Systems Manager or S3, or to CloudFormation as an updated CloudFormation stack. So how do we do this? If you see here, this is the first pipeline I've talked about. So the source phase is actually pointing to code commit, which automatically detects changes in code commit once I could commit the code, right? The code build is using, well, code build, right? It's running CFN nag on it, which is a nifty little tool that scans your CloudFormation template and against best practices for it. So if we have a look at what CFN nag does, is you can see that it found three warnings on my CloudFormation template. Is I have security groups ingress and that are not 32 or open to the world on egress, and which is again not the best practice, but for the sake of demonstration, I just left it as is. And if it was something really critical, it would fail. So going back to my pipeline, and finally the last step actually takes the CloudFormation template from the build phase after it has been linted and tested out, and puts it to CloudFormation as an updated stack. So if I look at my CloudFormation in this case, I can see that I have my web server prod, which is my CloudFormation template that runs my web servers. So, well, they run Bob's web servers. And if you can have a look at this, it's actually just running a simple Nginx web server with behind the load balancer. So it has two Nginx boxes sitting behind the load balancer. Nothing special. Now, how did we get this Nginx on it? How did we get the Nginx servers up and running on these boxes? Well, as mentioned before, we've used Systems Manager and Ansible. So this is an Ansible playbook I have created, which is ridiculously simple. It actually installs Nginx, starts Nginx, and it creates a user on this box. So this goes to a separate pipeline, again, as I mentioned before, which takes a little piece of code if there's a change in the Git repository, and then runs a build. Now the build phase actually runs Ansible linter on it and runs the native AWS CLI to upload the Ansible playbook to S3. Then from S3, we use AWS Systems Manager with State Manager to run an Ansible playbook. If we look at this here, it's running an Ansible playbook from this URL. And it's currently managing these two instances. Now, these two instances are defined here by tags. So when you create an association for State Manager, you actually define, hey, I wish to use either a resource group or I wish to filter my instances by tags. That means automatically, anytime a new instance comes into with this same tag, which is again being provisioned by CloudFormation, well, provisioned initially by CloudFormation, it's gonna be managed by Systems Manager within State Manager, thus meaning that it's gonna be running Ansible again. So let's make a small change to our CloudFormation. So this is not something you would normally do, but for the sake of demonstration, it's nice. Let's change the number of active nodes from 2 to 3. Let me save that, and then let me just upload this to the web server, to the Git repository. And now, I've pushed this piece of code to code commit. Hopefully, in the next couple of seconds, we should see some activity on the source field. So as soon as CodePuppet detects a change within code commit, it should start ingesting the updated YAML file as an artifact. As you can see, it's in progress right now. So as soon as it has ingested the YAML file, it will take it to the build phase, which again is gonna perform CFN mag on it, and at the end of the day, it will deploy it to CloudFormation. This will take a while. A few minutes. So what we can also see here is in the events page, as soon as this CloudFormation stack starts to update, we will see an update in progress on this end. So as soon as it goes to build, I'm going to switch over to code build. We can actually see in real time the output of code build, which is just a little terminal box-like window. All right, so we can see that it has transitioned now into code build. And for each step in this pipeline, we can actually see which commit message it's using. And I can click on this and see, hey, I've made this change to my little piece of code, right? So I've made a change to my CloudFormation file. Going back here, and let's look at the details. So we can see that this has, well, actually it has finished already. So again, no errors, just warnings for me to fix up my my security groups, but I'm being a bit naughty right now, so I don't care. Let's go back to code pipeline, and well, the build is still in progress because it's uploading the artifact. All right, so it came to the deploy phase, and soon enough, we should be able to see that our web server stack is update in progress. What this means is that we actually will change the number of EC2 instances from 2 to 3 in the autoscaling group, and this actually is already done. So as soon as the new instances come on, we should be able to see it in State Manager on AWS Systems Manager as an associated node. So the instances are starting up right now in autoscaling, so it takes a minute or so. And the great thing of that is that as soon as that node comes on and is associated, it's going to run the Ansible playbook. I have provided it as part of my systems manager, state manager, and it's going to be updated the same. So still just 2 instances. Until this, while this is still waiting, let's look at what happens with Ansible cookbook changes. So I'm not going to repeat the change here, but basically, because it actually takes quite a longer time for the Ansible cookbook to be linted. So what the linting does is actually we use a tool called Ansible lint, and it checks for, looking here, it checks the playbook for any potential issues. Luckily, there's nothing in here, right? So I have no issues. After this phase build, running command Ansible lint web server YAML, these are just some warnings which are not related to Ansible. There's no issues here, and it automatically goes to post build, which is actually running AWS CLI to upload said playbook to S3, which then it's automatically being provisioned from by systems manager to the instances. Now, let's see if this has been successful or not. If we go to autoscaling groups and look at my web server autoscaling group, I can see that I have 3 instances right now. Yeah, that's good. So all of them are healthy. All of them are in production, well, hopefully. And I think it takes a minute or 2 or a better page refresh for them to show up here as nodes. Well, not yet. So while we wait for that, let's actually let's go ahead and make some changes to Ansible. I have created here a user called Darko on the system, but let's just go crazy and create another user. So, and then let's do user, and then like this, Bob, right? Comment Bob loves as code. Then we'll leave out the UID and a group wheel. Now, if I save this and run git add git commit added Bob git push origin master, and again, like before, it's going to go through the same pipeline. We're gonna see the source phase being triggered, and it's gonna take the little piece of the code from the Git repository, package it up as an artifact, and push it to code build, and then code build will actually do something with it. We'll do the testing part. Let's see if something has changed here. Well, this is not nice. Well, the demo gods are. This is the way they do stuff right now, I guess. So let's give it some more time while we have a look at this. Just to emphasize on this, this is not how you actually deploy your application. While you can use Systems Manager and Ansible to deploy your web application, I would leave the web application deployment or any kind of application deployment, the thing that actually provides you with the service you want or that actually earns you money. I advise that you create a separate pipeline using some other tools. Again, you can use Code Pipeline, Code Build, and Code Deploy to deploy that actual application code on your instances, because it's necessary that we separate infrastructure, configuration, and application code bases. So that a change in infrastructure is not necessarily a change in configuration, and a change, well, in configuration is not necessarily a change in your application. So making many Git commits for just the sake of changing some little piece of your code, if that little piece of code is bundled with your configuration management, that doesn't make a lot of sense. So I don't have that demo today, but you can think of it in the same way as this is, but just for application deployment. So if you're deploying your little Python-based Flask web application, you can put it to code commit, put it into code build to run your PySpec on it, and then use code deploy to actually take that finished binary and put it on your running web servers. So looking at this right now, we can see a whole lot of things happening. So because this is running, code build is running Ubuntu, I'm actually running pip to install Ansible lint. And if you can see, oh, something happened. Build success false. Let's see. You can see here 502 all tasks should be named. I made this mistake by purpose, so I can demo this. Of course I did. And so what I can do here is I can take this and then do this and then this. And this is just an Ansible thing. If I again git add and git fix it Bob, git push. Now this actually prevented a potential bad issue on our configuration. Imagine if the configuration was something that could break your production. You wouldn't want that, right? So this way we ensure that no matter what Bob types in his Ansible playbooks or any other configuration management code, it's going to be tested against. And only the successful tests, if you write your tests good enough, are going to be published to production or any other environment. This prevents you from accidental, well, failures. So let's see if something has changed on this side of the world. Oh, good. Cool. We see we have a third instance now being managed within State Manager. And again, it's running the same piece of Ansible code, and it's running Nginx on it. So if I try to refresh this load balancer many times, hopefully I will never get the 502 error here. So yay. This is a very basic example of how this works, but yeah. So let's just see this through the end. Let's make sure our piece of Ansible code goes to production. I usually like to do these things live or in front of people, because people can scream at me when I make a mistake in my code. Looking at this, it's fine. It looks good, hopefully. Bob wheel, all good. Let's see what. Well, even if I did make a mistake, as I said, code build would detect this. Well, Ansible intro would detect this and prevent it. Again, you can expand this to be much more complex and much more full of it, right? So instead of just using Ansible Linter, you can use Test Kitchen for actually deploying an EC2 instance that you will run the Ansible code against to see how it will react. And when we talk about the CloudFormation part, there's a lot of complex examples where you can have multiple branching pipelines where you branch out to a staging environment and then you test out the staging environment and you have to manually click approve. And once you're happy with the way your staging works, and then those changes get merged back into the production environment. So there's a lot of you can build on this, and just the tool code build gives us a lot of flexibility, as you can run any command on it. Well, not any command, but a lot of custom commands on it to actually develop your own tests. So it's not just a matter of that. And to show you quickly how do we define what we run on code build is there's a build spec file which just runs a bunch of commands. So in this case, this is the build spec for Ansible. So it's just installing Python pip. It's installing Ansible lint, and it's running Ansible lint against the YAML file. And then after that is done, it's publishing the playbook to S3. And hopefully it succeeded right now. Excellent. Now, let's see if we can see this change, right? I mean, I've added a user, so really depends on what change am I gonna see here, or actually, it's gonna actually take a half an hour for this to apply. But let's do it right now. Let's do it manually. If I would wait, it would take me a half an hour for the instances to apply playbooks on it. But I did it right now. So let's log into one of these instances and see if we can see the user Bob on it. To log into these instances, I'm going to be using Systems Manager Session Manager, which is quite a nifty way to do this. It actually uses the web console for SSH access, right? Or quasi SSH access. So if we sudo cath etc password, we should be able to see Bob and Darko at the bottom. So we can say that that our settings have been successfully applied. Okay, I guess it's time to me to switch to this thing, and let's do a bit of recap. So we've seen how do we manage infrastructure on AWS using CloudFormation. Again, there's other tools you can do this. Terraform comes to mind, right? Some people do like Terraform. Some people like CloudFormation. And we talked about how can we use CloudFormation to provision our infrastructure, and how can we do it in an automated manner using pipelines. The same goes for how can we do configuration management on AWS. Today, I've demoed Systems Manager and Ansible. So, and again, same as before, we use the pipeline to automate these changes. But that being said, you can use any sort of configuration management on this as well. So I've had demos in the past of using the same thing with Puppet and Chef on OpsWorks by utilizing pipelines. So, and again, all of this should be automated, and the automation doesn't mean it goes fast, but it goes fast and goes safe. So Q&A time. One moment. Let me have a look. So there's a question, can we also automate changing AWS settings? Depends on what settings you mean. So if it's anything that can be changed by CloudFormation, yeah, of course. So EC2 instance sizes can be automated. So it's not, when I say changing configuration, this means changing the settings on the EC2 instances, but with CloudFormation, we can automate changing of basically anything that CloudFormation can change and manage. So so that's one thing, right? So if you want to change the size of your autoscaling group, or if you wish to change the engine running on your RDS database, you can use CloudFormation to automate the changes. And again, the same with it can be automated as well using the pipelines, again, because it's using CloudFormation. At the end of the day, all of that can be applied. So second question we got in, what's the difference of configuration and infrastructure as a definition? So this again, this has always been a debate of how some people see infrastructure, infrastructure as code, and some people see configuration as code. I personally, in my professional career, like to split those things up, as infrastructure management actually provisions the bare bones infrastructure. So if you think of it like a software-defined data center concept, right? So something you can actually the underlying things in your infrastructure. So from network to the actual EC2 instances to ECS clusters, right? Or to any sort of AWS service you want. And then configuration management is usually things that run on the operating system as well. So it has another layer of abstraction on top of it, right? So it's not the configuration of AWS resources, but the operating systems running on top of them. And number 3, is there a complexity limit? I guess this question is regarding the pipelines. There are some limits when it comes to pipelines, the number of steps you can take, but I believe I don't know the limit by heart. So of course there is a limit on the number of steps you can have in code pipeline. So definitely, but I think you would exhaust the complexities before you reach that limit. Question number 4. What are possible sources for Ansible playbooks? Only S3. So in this case, I do believe it's only S3 for the system manager on session manager, on state manager. A lot of managers. So if you look at this, let's try to create another association for state manager. Not this, but this. Create association. If I choose myself an Ansible playbook, I can actually put it on any HTTPS location. So if it's public, yeah, of course, right? And if not, I can use S3. And again, if you want, you can actually paste your entire playbook in this little text box, which is not the ideal way, right? But even if you want to keep your Ansible playbooks in some sort of a Bitbucket repository or somewhere else, thanks to Code Pipeline, you can actually ship that playbook after it has been tested to an S3 bucket as an artifact. So that's one of the ways to approach all of this. Number 5. So what happened during code commit that took so long? It takes a minute or so because what happens there is actually code pipeline is being notified by CloudWatch that there has been a change. So usually the delay is something between, hey, CloudWatch notifying code commit, hey, something has happened. Sorry, code pipeline that, hey, something has happened. I've seen a change. And then while code pipeline ingests that change, because code pipeline doesn't just pass on the code commit to code build, it actually takes the content of that Git repository and packages it up as an artifact and pushes it to code build or any other stage you encounter here. So that might be the potential cause of a delay. Number 6, is there a web-based training for that issue available, in particular connection with Ansible? So far that I know, there's no training on AWS for this, but that's something that we would need to confirm. I've actually, and Systems Manager has I think almost since the beginning of introduction of run commands, it had the option to run Ansible playbooks. Integration of Ansible, just simple Ansible playbooks should be simple enough. But for training, I wouldn't know. We would need to get back to you on that. Number 7, how State Manager knows that execution is done by Ansible. So first of all, when we configure State Manager, we tell it, hey, run Ansible playbooks. Now, a quick note, you are required to have Ansible running on your instances before. So if you can see here, I have in my CloudFormation template a piece of user data that is somewhere. Okay, yeah. So I'm using pip to install Ansible. So I must have Ansible running on it. Then what happens is when State Manager runs the Ansible playbook, it actually gets either a success or a failure back from the EC2 instance. Now, in this case, I just get a success or a failure. For further information on what exactly failed, you would have to go into the instance or have those logs being shipped somewhere else. I do find that a bit inconvenient, but that's the way it works right now. But expect furthermore integration with CloudWatch at one point. I'm sure that's going to be running on it. So Next question, question number 8. Do you have a code build example for file for CI/CD deploying of AWS Lambda functions written in Python? So I would like to use code commit together with code build for automatic deployments of Lambda functions a.py. Oh yes, so I don't have an example myself, but I've actually had chance to look at this, and there's various examples of this. So my advice to you is just Google code pipeline Lambda and SAM or something like that, and there's a full example of code of build spec files for this, and it's actually quite a common pattern for people to have Lambdas deployed by a code pipeline. Question number 9. Can we use different systems or containers for code build to run our build on? Of course, that's a definite yes. So once you let me try to do this. So if you go to code build and I want to like add another build step, so in build 2, I can. So for the build, I can even use Jenkins. I can use Solana CI as well. But if we're gonna stick to code build has a lot of let's use a demo. Oh, let's create a project, right? So if I create a project for code build, I can have various environments. So I can have my own Docker image because code build is actually using a Docker container in the backend, right? I can have Ubuntu or Windows Server. So for all of your Windows folks who wish to compile Windows-based stuff, you can use a Windows Server based code build. And if you choose Ubuntu, you can actually choose a lot of runtimes. These are specific images for specific tasks, right? In my case, I used Ruby because both of my projects require, well, at least the first one, the CloudFormation one requires Ruby, so to install the gem, the CFN gem, right? So, but yeah, you can do this. And again, if you want, you can use your own custom image as well from the any container repository you want. Okay, I guess that's all the questions. Let me open this thing officially. Yes, thank you very much for attending and bearing with me through this entire webinar. I appreciate your attendance, and I really hope that you have gotten something useful out of this. Thank you very much, and I wish you a nice day.